Hello, everybody. In this slide one, we're thinking about Dora, how she's exploring the Screamer here. So we have to remember the Screamer. That was that one scary Ferris wheel that we started with at the beginning of this unit, way back when we were in school. And it had the height of the rider on the Screamer was given by y is equal to 100 sine of x, where y was the height in feet and x was the angle of rotation. So if you remember, and here's a picture of it right down here, it was half above ground and half below ground. So when we're being asked, circle the maximum height of a rider on the Screamer to the right and enter it below. Okay, well, I know that my maximum height is right here. The radius of this Ferris wheel is 100. And so the height will be 100. The maximum height will be 100 feet. Now it's asking us to, in a different color, circle the minimum height of a rider on the Screamer and enter it below. So I know that the lowest it can be is 100 feet below ground, which we'll write as negative 100 feet. Okay, negative 100 feet. Now let's read about Dora. Dora is curious about riders on the Screamer, about when riders on the Screamer will be 50 feet above the ground. She thinks that riders will be at 50 feet above the ground once in a full rotation. Do you agree? Explain below. Well, hold on a second. 50 feet above the ground is like saying 50 feet on the y-axis. So 50 feet above the ground would be around right here. And I know that there will probably be two different spots on this Ferris wheel at this height. So I'll move it right to there. So no, I do not agree with Dora. No, I do not agree with Dora. There are two spots on the Ferris wheel that are at a height of 50 feet. Okay. Circle where a rider will be 50 feet above the ground on the Screamer. All right, well, I know it's at this height. I know that there are two intersections right there. So I'll circle one right here and one right here. So those are the two spots, okay? Dora thinks that she can write an equation that could help her solve for the angles of rotation where riders are at a height of 50 feet. She first wonders if 50 feet is an x value or a y value in this context. Insert x or y in the blank below and then briefly explain why. So 50 feet, well, I know back to way up here, y was the height in feet. That is what we know this y variable stands for. Our feet are on the y-axis. So 50 feet is a y value because the y values are how high the riders are. Whoops. Or how high the riders on the Screamer are. Make that smaller to make that fit. Okay. Cool beans. She first starts with the equation for the height of a rider on the Screamer. So it first starts with this y is equal to 100 sine of x. Now we're being asked to write in 50 into the equation. Okay, well, it's a y value, so I'll replace this y with this 50. All right. Now we want to solve for x. So to solve for x, undo the multiplying by 100 on both sides. Well, okay, if I divide by 100 on the right side, these will make 1. Let's show that. Divide by 100 on the right side. 100 divided by 100 is 1, or they cancel out. If I divide by 100 on the left side, well, 50 divided by 100, we're not quite sure. We can use a calculator, but I think it's going to be 0.5. Well, that's a nice number. 0.5 right here. Okay, 0.5 is equal to sine of x. Now solve the equation. Show your thinking by drawing lines on the unit circle and the graph below. Write your solutions in both degrees and radians right down here. Okay, I had to kind of think about this for a little bit, and it's a helpful reminder right here. Sine on my unit circle is a y value. So I am going to think about this as a y value. So 0.5 is a y value. I'm going to put that on my unit circle right here. Here's my y-axis. There's where about 0.5 is. I'm going to make a horizontal line again so that I can see those two intersection points right here. Okay, so let's circle these suckers right here and right here. Now, the question is back up at the top where we see our three special triangles. Which one of these have a y value of 0.5? And y value is the second number. So I see a 0.86, that's not 0.5, 0.7, that's not 0.5, but hey-oh, here's a 0.5. It's our red triangle, and our red triangle stands for 30 degrees in our reference angle, a 30-degree reference angle. So let me show this by making a triangle right here with this first intersection point. I know that this angle is 30 degrees. 30 degrees. So actually I know what my first solution is, but before I do that, I forgot. I want to show the same thing on my graph so I can double check my answers. 0.5 is a y value, so I'm going to go to this bit on the y-axis, right between 0.4 and 0.6. And I'm going to make a horizontal line at this height, and I see that there are two intersection points as well, something between 0 and 45, and another one between 135 and 180. If I were to drop a line from these two intersection points, I can kind of estimate something right before 45. What could that be? It might be 30. So that 30 degrees is making a lot of sense right now. But now for this other one here, I want to think about a reflection of this triangle. So to do that, I'm going to reflect this line over the y-axis, and I'll make this color a little bit different to help it stand out a little bit. And because we're reflecting this triangle over, this angle also is reflected over. So I know that this is again going to be 30 degrees. So let's see. Now we have to think about the second solution. So if I start here at 0, if I go all the way around here to this, how many degrees is that angle of rotation? I know that if I go all the way around halfway, that this is 180. And I know because of this angle is 30, then this section right here is also 30 degrees. So if I go halfway around to 180, but then go back 30 degrees, I should get at my last and second solution. So 180 back 30, that's the same thing as saying 180 minus 30. So all right, I'll write that down right above here for my work. 180 minus 30 is equal to, yeah, that's 150. Now, let's think about this. 150, let's see if that works on our graph here. 150, is that in between 135 and 180? A little bit closer to 135? Yeah, that works really well actually. We just found our second solution in the graph and on the unit circle. So now let's fill out our answers here. Our first solution was the one in the first quadrant, 30 degrees. Second solution was our 150 in the second quadrant. And our radians can be this. All right, how many times does 30 go into 180? Well, if you forget, 180 divided by 30 is 6. So I know that's going to be pi over 6. 1 pi divided by 6. Then for 150, let's think how many 30s will go into 150. 30 times 5. 5. So I have 5 pi over 6 for that one. Oh, not over 5, over 6. And take that down a little bit right there. Here are my two answers. Thank you very much.